In this video, you will learn about solving systems of equations by substitution. First, let's review the steps to solve a system by substitution. First, you have to choose one equation and solve for one of the variables, meaning to get x or y by itself. Then you're going to substitute this into the other equation. This results in one equation with one variable. Then you will solve the equation, substitute your value into either of the original equations and find the other value. Then finally write your answer as an ordered pair. And lastly, you can check your answers by substituting the point into both equations, and it should satisfy both of them. In our first example, the two equations are y equals 4x minus 11 and 2x plus 2y equals negative 12. Since y is already by itself, I can take this entire expression of 4x minus 11 and substitute it in for y in this equation. So I'll have 2x plus 2 times 4x minus 11 equals negative 12. Now if I want to solve this equation, I first have to distribute the 2. So I'll have 2x plus 8x minus 22 equals negative 12. Combine like terms, so I'll have 10x minus 22 equals negative 12. Solve to get the variable by itself by adding 22 to both sides. So I'll have 10x equals 10, and then lastly divide both sides by 10 so that x is equal to 1. Now that I know that x is equal to 1, I can take this value of x and substitute it into my original equation. So I have y equals 4 times 1 minus 11. So that'll be y equals 4 minus 11, so I'll get y equals negative 7. So the solution to this system is 1 comma negative 7. In our first example, the equations are x equals 3y plus 1 and 2x plus 4y equals 12. In this example, x is already solved by itself in this example. So I can take that entire expression and substitute it in for our value of x. So it'll be 2 times 3y plus 1 plus 4y equals 12. Now to solve this equation, I first have to distribute the 2. So I'll have 6y plus 2 plus 4y equals 12. Then I'll combine like terms to have 10y plus 2 equals 12. Solve to get the variable by itself by subtracting 2 from both sides to get 10y equals 10. And lastly, divide both sides by 10 so that y equals 1. Now I can take this value of y and plug it back into the original equation. So I have x equals 3 times 1 plus 1. That becomes x equals 3 plus 1. And finally, x equals 4. So the solution to this system is 4 comma 1. Now first I'm going to rewrite both of my equations. So I have y equals negative 6x plus 5 and y equals 4x minus 5. Now what we should notice is that both of these equations have y already by itself. So it doesn't matter which one we choose to substitute into the other. So I'm going to choose to substitute this first equation in for y in the second equation. So if I rewrite this, I'll have negative 6x plus 5 equals 4x minus 5. And now I want to solve just like I would any other equation. So I'm going to bring all my x's to the left. So in order to do so, I would subtract 4x from both sides. So I'll have negative 10x plus 5 equals negative 5. Bring all the numbers to the right. So I would subtract 5 from both sides. So I'll have negative 10x equals negative 10. And divide both sides by that negative 10 to get x is equal to 1. Now I'm going to take this value of 1 and plug it in for x in the other equation. So this means I'll have y equals negative 6 times this value of 1 plus 5. So if I finish evaluating, the negative 6 times 1 gives me a value of negative 6 plus 5. And when I combine those, I get y is equal to negative 1. So our solution, written as x comma y, would be 1 comma negative 1. Now we're going to discuss the special cases associated with systems of equations and solving by substitution. So if the statement results in a true statement, we say that we have infinitely many solutions, meaning use something like 5 is equal to 5. If it results in a false statement, we would call this no solution. So something like 4 is equal to 0. So for this example, I'm going to start by rewriting my two equations. So I have 3x minus 3y equals 5, and x equals negative 4 plus y. Now again, we notice that x is already by itself, so I'm going to take this entire value and plug it in for x in the other equation. So it becomes 3 times the negative 4 plus y minus 3y equals 5. Now, if I were to solve this, I would first distribute. So I get negative 12 plus 3y minus 3y equals 5. Now I can combine like terms on the left side. So I have 3y minus 3y, and when I can't add those together, they cancel out. So it becomes negative 12 plus 0y equals 5. And when we know we have that 0y, we really don't have to write that because the 0 means it's not there. So this ends up meaning that my answer is negative 12 equals 5. However, this means that we've run into an issue, so it's a special case. Now, because this is a false statement, we would say that this is no solution. Now, in this example, I'm again going to write out my two equations. So I have negative 4x plus 2y equals negative 10, and y equals 2x minus 5. So since y is by itself, I'm going to take this entire value of 2x minus 5 and substitute it for y in the other equation. So it'll become negative 4x plus 2 times the value of y, which is 2x minus 5, is equal to negative 10. Now if I solve this, I'm going to start by distributing. So the negative 4x will stay the same. 2 times 2x becomes 4x. And 2 times negative 5 becomes minus 10 equals negative 10. Now I can combine my like terms on the left here,
However, when I combine this negative 4x plus negative 4x, that results in 0x. So I can write it out as being 0x minus 10 equals negative 10. But we know that if we have 0x, it really cancels out and we don't even need to include it. So this means our answer is negative 10 equals negative 10. So the x's canceled out, so this is one of our special cases. Now, because this is a true statement, we conclude that this is infinitely many solutions.